Okay folks, this is just a little bit of information that you're going to need to do Ohm's law type problems. I'm going to teach you some metacognitive strategies that will help you understand this type of circuit. So for a simple series circuit, you basically have your battery and your resistor, and this is a series circuit. Now it would be worthwhile looking at all the formulas and all the information that comes before these videos, before you actually have a look at these videos. These videos are really here to supplement what we've already covered. So we talked about our VIR triangle. You don't have to remember Ohm's law if you can remember that diagram. And if you want to work out what voltage is, you cover voltage up and you end up with I times R. And if you cover up current, you end up with V over R, etc., etc. So that's the way that you use this type of diagram. Why? So that's your VIR triangle. So that might be an easier way of remembering the formula. Now, when you're dealing with a series circuit, you might have, let's do real world examples, 10 ohms here and 20 ohms here, and you might have 30 volts over here. Conventional current flow goes from the positive to the negative terminal. The positive is always the bigger one. So our conventional current flows this way. The first thing you need to remember in a series circuit is that the current is going to be constant regardless of which resistor it's traveling through. Now, you might get in the mindset of that, you know, if it's a 10 ohm, it's less resistance, so there'll be more current in the 10 ohm than the 20 ohm, and you would be incorrect in that assumption. Okay, so just remember your current flow is constant. So if I stuck a current meter in here, or here, or here, or over here, that was measuring my current, the value would all be the same throughout this circuit in a series sense. Okay, so if I wanted to work out current in this circuit, I would cover up I, and I end up with V over R. So I would have to put I equals V over R, which equals 30 volts over, and we need to work out our resistance. And we know in a series resistance circuit, you would add those two values together. So it's 30 over 30, because 10 plus 20 is 30. And we end up with 1 amp. Okay, so that 1 amp current is flowing through the 10 ohm and through the 20 ohm. Okay, don't ever think that because the resistances change that the actual current will change. So that is the first thing that you need to be mindful of. Just remember that. That's, you know, because you will come unstuck if you think that the current changes as you move from place to place. Okay, so we'll just rub that circuit out. So that's the first thing you need to remember. Now, there's another thing that is described by a law that's called Kirchoff's current law. Okay, we don't probably need to remember that law, or what it's called, but you need to remember this fact, that if you have a circuit with a parallel branch, then you might have a change in current depending on which part of the branch you're looking at. So if you've got this time you've got your resistor R1, and then you branch off into a parallel situation, and then come back into series. In this situation, the current is going to be the same if you look at it from the point of view of turning that parallel branch into a single resistor. Okay, so you would calculate the value of that parallel branch, and then you would have a constant current flowing around this entire circuit. But if you were to measure the current, say, in this part of the branch or this part of the branch, you would have different currents. And there's a good reason for that, and it comes down to the voltage drop across from, if you were to measure voltage from here to here, it has to be the same because it's the two same points. So if you've got different value resistors, we know that voltage equals current times resistance, V, why isn't this working? V equals I times R. So if this value here was, say, let's say 1 ohm, and this was 2 ohms, okay, and the current flowing around this entire circuit was 1 amp, well then you know that for this voltage across this situation here to stay the same, because you're measuring across the same 2 points, then you need to have different currents flowing in each of these branches. Okay, so you've just got to remember that Kirchhoff's current law, let's make this really simple. Kirchhoff's current law says that the current going into the branch is the same as the current coming out. Okay, so it's a series circuit up to here. We've got 1 amp coming in here. If we were to have two resistors that were the same, so let's make these both 1 ohm, then the current would, if you had 1 amp flowing, you'd have 0.5 amp flowing through that side and 0.5 flowing through that side. So you end up with 1 amp coming out the other side. Because in a series circuit, we said that current never changes. But when you come into one of these parallel branches, if you've got different value resistors, the currents will be different in each of those branches. Okay? And the current splits up to go through those branches. So if for instance, let's draw a really simple circuit here. If we had 1 amp coming in to the branch, and we have 1 amp coming out, of course, because that's what Kirchhoff's current law says. If we have a 1 ohm here and a 2 ohm here, then because this is a lower value, this will be 2/3 of an amp, and this one will be 1/3 of an amp. Okay, and when you add 2/3 and 1/3, you get 1 again. So that's another thing you've got to remember, that the currents through the actual branches in a parallel circuit are going to be different if the actual resistances are different. Okay, if they're the same resistances, Kirchhoff's current law will split them evenly if you've got 2 resistors. Okay, so that's another thing that you need to remember. Okay, that will be helpful in understanding how a circuit works. So just remember, in a series resistive circuit, we'll summarize now. In a series resistant circuit, I'll say series R, I is going to be constant, okay, if the resistances don't change. But in parallel, we've got Kirchhoff's current law in operation. And that's that law we just talked about, where the current that's flowing around the circuit is divided in the branches, depending on what resistance you've got. And we can calculate the current in each branch by using the idea of V equals I over R. Okay? Sorry, I equals V over R. So that's a few strategies that may help you in doing this type of circuit. So have a play with that, and we'll do some real life problems shortly. Bye.